All right. So we're going to look at a couple special kind of series here. We got a telescoping series, or telescoping series actually. The sequence is telescoping, but this series is what we're kind of looking at. Okay, and what we have is we have something that looks a little bit like that last one there. We've got B1 minus B2, B2 minus B3, B3 minus B4, so on and so forth. Okay, notice that all the middle terms here will cancel out. Okay, so the sum, when we have this kind of setup, the sum will just be the first thing minus the last thing, because all these middle ones will cancel out. That's negative B2, positive B2, negative B3, positive B3. And this will all cancel out, except for the beginning and the end. Okay? So we get a summation for a telescoping series. Is the first is B1 minus B sub n. Okay? So this will allow us to have a limit only if the limit of B1 minus Bn. Another way to say that is if the limit of B sub n exists, then the limit of the series exists, because B1 is a finite value. So the first thing we've got to figure out is if the series is following this kind of telescoping pattern, this plus minus pattern. So let's try this one. First, we got a suggestion here to use partial fractions to break this up. So let's try that out. Remember how to do that? So we have this. We want to factor this first of all. So let's see. This is a difference of two squares. Square root of the first thing is 2n. So we have 2n plus 1 and 2n minus 1. Okay. And we want to make that equal to 2n plus 1 and plus b over 2n minus 1. Okay. So I'm going to take this and we're going to combine them into one fraction. That's the whole idea of partial fractions. So I want to make this look like this form, and then we'll figure out what this a and this b is. Okay, so if I multiply this by 2n plus 1 over 2n plus 1, and multiply this by 2n minus 1, 2n minus 1. All right. Well, then we have a common denominator, and we can simplify it, right? Or write it as one fraction. So a times 2n minus 1 plus b 2n plus 1 all over 2n plus 1 times 2n minus 1. And the big idea is that this thing is equal to this. And since those two fractions are equal, the tops have to be equal. That's how partial fractions works. So 2 is equal to a times 2n minus 1 plus b 2n plus 1. All right. We need to find a and b, so we can pick. This has to be true for all n is the idea, right? So if n is 1/2, so if n is 1/2, this will go to 0, right? So that'll make this whole thing go to 0. And we have 2 equals, first part goes away, b times 2 times 1/2 plus 1. And that means 2 times 1/2 plus 1 is 2, so 2b equals 2 divided by 2, and b equals 1. And with that, we could try one more. Let's let n equal negative 1/2, and kind of the opposite happens. And so let's see, negative 1/2 will go into here. Negative 1/2 will give us 2 times negative 1/2, which is negative 1. So this is negative 2a. And when you plug in negative 1/2 here, that makes 0, and the b goes away. So this tells us that a is negative 1. Divide both sides by negative 2. All right. So all that to say this, that this summation up here from 1 to infinity is the same as, so this one fraction can be written as these two fractions, but we're going to put negative 1 in for A and B and 1 in for B. And I'm going to actually flip it while I'm at it here. Okay, so we have, let's see, we have the B value, which was positive 1, and the A value is negative 1, right? Okay, so the B value is 1 over 2n minus 1, because that's the way I set my B up. And then we have A is plus negative 1 over 2n plus 1, but we'd like to bring that 1 down here, right? Which we know we can, right? Remember, we realize that? Okay, because negative 1 over 2n plus 1 is the same as negative 1 over 2n plus 1. All right, so we can put the negative out front or up top, same thing. So this is the same thing. Well, what does this mean? Let's write out our first few terms. Plug in 1, we get 2 times 1 minus 1, that's 1. So I'm going to write as 1 over 1 minus, plug in 1, we get 1/3. Now plug in 2. Okay, so we're working through our series here now. Plug in 2, I get 1 over 2 times 2 minus 1 is 3. Minus, plug in 2, this becomes 5. That's the second term. The third term, plug in 3, we'll do one more here. Plug in 3, 2 times 3 is 6, minus 1 is 5. That's 1/5. Minus, plug in 3, we get 2 times 3 plus 1, that's going to be 1/7, right? So we have 1/7. All right, dot, dot, dot. Okay, and then I'm going to copy this down, 1 over 2n minus 1 minus 1 over 2n plus 1. So that is the nth partial sum, and then it actually goes on forever for the actual series. So what's going to go on? Well, what's happening here? So the s sub n, the nth partial sum, is going to be what's left over when a bunch of this stuff cancels. Well, what's going to cancel? The negative 1/3 is going to cancel with the positive 1/3, the negative 1/5 with the positive, the negative 1/7 with, they're all going to cancel except for the first and the last. So in the end, the nth sum is 1 minus 1 over 2n plus 1. Okay? So the only thing left over is the first and the last. Okay? So the question is, will this converge? And it will converge if this converges, which it does. Okay? So the limit, we can actually find the limit. It's an easy one here. The limit of 1 minus 1 over 2n plus 1 as n goes to infinity. Well, as n goes to infinity, this goes to infinity, right? And so we have 1 over a very large number, so this goes to 0. So this is equal to 1, because the limit of 1 is always 1, minus 0, which is 1. So it converges because the limit exists. All right? So there you have it. That's how telescoping series works.